Okay, again, I gave you 4 problems to practice finding the area between curves. So we're picking up with problem number 2 in this video. If you missed the intro video, watch the intro video. Correct answer to number 2 is 10. If you got 10, then you are probably ready to move on. If not, here we go. Let's work it out. So this is a pretty easy one in terms of the function. So I've got y equals 4 or f of x equals 4 as my first curve that I'm given, and I'm giving myself a quick sketch of that. And sometimes I like to just, and then I've got y equals x, and that's this, or g of x equals x. So the blue one's on the top, so I'm going to do area equals integral of top minus bottom is going to be 4 minus x. And that's it, and I'm doing from 0 to 6. Limits of integration coming from this part right here. So this one, like I said, should be easier than the last one. 4x minus x squared over 2. I'm doing my antiderivatives, and I'm evaluating that from 0 to 6, so let's just plug them both in. Using parentheses because I've got 2 terms to plug in, so I don't want to mess up my signs. 4 times 6 minus 6 squared over 2 minus 4 times 0, and that's going to be 0. So be careful, it's not always going to be 0. In the last one, did we have 0, and tangent of 0 was, cosine of 0 was not 0. So it doesn't always go away, but in this case it does, and I get 24 minus 36 divided by 2 is 18, and I got 24 minus 18 is 6. Wait a second, 6. Didn't I say the answer was 10? My calculator told me the answer was 10. Yeah, I cheated. I put it in the calculator. So you could do that too. You could check and put it in the calculator. No, actually, my calculator didn't tell me the answer was 10. My calculator told me the answer was 6. My calculator messed me up too. What told me the answer was 10? Geometry told me the answer was 10. Let's go back to this graph for a second because I didn't do a super specific graph. And if we actually take a little more time here, this point right here is not less than 6. That point is 4, 4. And what we need to recognize about that is that if that point is 4, 4, then after 4, because my integral is going all the way to 6, so I'm doing the area all the way to 6. And from 4 to 6, my top curve changed. So for this first region, I'm going to call this region 1. My top curve was the 4, and my bottom curve was the y equals x. And so I did find the area there, but then I switched them when I got to region 2 over here. So region 1 and region 2, something different is going on. Let's do geometry for a quick second. We got 2 triangles. Triangle 1, 1/2 base times base, or base times height, 4 times 4. I'm getting the area of 16 divided by 2, 8. Triangle 2, 1/2 times 2 times 2. So that's 4 divided by 2, which is 2. Do you agree with me that the total area of the 2 triangles added together is 10? Yeah, you can't disagree with the geometry. So we have to get an answer of 10. We've got to figure out what's going on, and it has to do with something with this top and the bottom switching. And if you go back to what we did with areas, and with our, I told you to kind of entertain the idea of thinking about a normal integral area under a curve being this. There is a second curve, but my second curve is just 0, so I just don't worry about it. But then when I have under the curve, or under the x-axis, I have to do a negative because my first curve is really 0. So what's happening is by switching this, we're really getting a negative area. And we have some areas canceling each other out. You could think of it this way, that there's a triangle here and a triangle there that are canceling out. And what we really found is we found the area of the remaining trapezoid right here. That's what this 6 is. So we have to add back in that triangle twice, and that area of that triangle was 2. 2 plus 2, there's the 4 that I'm missing to get this 10. But supposing I couldn't picture this, supposing these weren't triangles, supposing I couldn't do geometry, what's my strategy going to be? We're just going to tweak our strategy, and we're going to take this, and we're going to divide it into 2 integrals. So sometimes we have to do this. When the top curve changes, we have to split it into 2 areas, and we're going to do from 0 to 4 making my limits of integration based on where my top curve is the same. So basically finding this point of intersection, which we already did. And for the first one, I'm going to have the 4 in the first part, and then I'm going to have minus my x. And in the second one, I'm going to reverse them. So my first curve is going to be x, and then my second curve is going to be the 4, because my top is now the y equals x, my bottom is now the y equals 4. You'd probably be fine from there if you want to keep sticking along. I'm just going to evaluate both these integrals, so it's going to seem a little repetitious. But good to know that calculus is going to get us the same answer, or good to see that. So I'm going to do the first half first. Sometimes I just like to keep it separate so I don't mess anything up here. 4 times 4 minus 4 squared over 2, and then 0. 4 times 0 minus 0, so that's gone. So that's giving me 16 minus 16 divided by 2 is 8. So that's giving me 8. So that first one I got an area of 8. Same thing we got with this triangle right here. So that's connecting with that. Let's try the second one and plugging in a 6. 6 squared over 2 minus 4 times 6. And then minus. This is why I set up the parentheses. Told you I gotta think of a big picture here of, okay, plugging in the first, plugging in the second, subtracting the 2 for my limits of integration. Otherwise I lose my place. 4 squared over 2 minus 4 times 4. And this gives me 36 over 2, which is 18. 18 minus 24 minus, and then I have 16 divided by 2 is 8 minus 16. So I have a negative 6 minus a negative 8, and that's giving me 2. That 2 corresponds with the area of my other triangle, and the original problem, let's go back to this. I had a plus sign in the middle. I just figured out I have 8 plus 2. There's my 10. Bit of algebra, not super hard, but new concept from this video is we need to determine if there's an intersection point between my two curves within the area or the region that I'm finding the area of, and then I have to split it up accordingly. Okay, so good idea to maybe add to your notes. If you have notes on this, if you wrote down from the original video, just add a little note there that sometimes the top curve can change. Okay, see you in the next video.